So last class, what were the two topics we did in the last class? What were they? Yeah, give me the names.
It's two math. If the math off.
Yes, but I want the name. I want the name. Give me the name. What's the name of what I did in the last class?
Kinetic.
No. Do you remember, Mustafa? What is it? Yeah.
It was the center of gravity.
That was one.
Okay, there's statics.
What the heck? My screen size is messed up.
So you have to record it from...
No, I don't think I have to do that. Oh. Okay. One more. There, okay.
Statics.
That's better.
Statics.
Okay, so the...
What's going on?
I don't know what's going on. It's not the ink that's the problem. Look, you see this red dot?
Yeah.
I want to write here.
Yeah, but it's going on.
It goes here.
Yeah, do it.
Oh, maybe it's loose.
No.
Okay, I'll try my best.
No, just remove it and put it again.
You think so? Oh dear. Okay. Maybe for the next class I'll fix it. I'll just try my best for it now, okay? Alright, so...
You can do it.
I can do it. There now. Last class... So what were they called?
Statics.
Yeah, so we did turning force.
The center of gravity and the statics. Well, that we did.
Yeah. But the name statics now, turning force.
Turning force.
Yeah, what were the names for turning force? You said it earlier, Albert. Turning force. Also another name, torque. And another name. I gave you three names for turning force. They all mean the same thing. Moment. It should be one word.
Moment.
Yeah.
Okay.
And then in the second class, what did we look at? It was center of gravity. Okay?
Yeah.
Now, for this class, we're going to continue with torque and moment and turning force. Please, be patient. And we're going to look at a very special type of problem. So here, let's say, here is force, let's say 10 newtons. And then here is force 10 newtons. What's interesting about this example I just drew for you?
Zero.
What's zero?
The net.
The net force is zero. So will this move up or down?
No.
No, it won't move up or down. But will it do anything?
What?
Will it do anything?
No. Nothing. Will be
It'll do
like-
nothing. Completely nothing? What do we think? Ted, you have an idea?
What's this?
The question is, will this do anything, this picture?
Well,
Like picture it like, this is like, it's like a lid for a bottle.
okay.
Say Coca-Cola.
Why is this topic come?
I'll tell you in a moment. I'm just doing a sort of special example from last class. Will this lid do anything? It won't move up, won't move down. What will it do, yes, Ted?
I don't know what.
What's the name of this? Come on.
Huh?
What do you call this in English?
Turn around.
Turn around.
Oh. Oh, yes, turn.
You should know this, Ted.
Turn.
It'll turn.
Yeah, turn.
It won't move up, it won't move down, but it will turn.
With the clock.
With the clock, clockwise, yeah. This here is what we're going to do today. And this type of problem is a special type of problem. And it's called a couple. Couple. And a couple is when you have one force
Two.
going up maybe, and then one other force,
Going down.
and it's going in the opposite direction, like maybe going down. So the net, what's the net going to be?
0.
The net will be 0, but it will still turn. Yeah? Now, let's go back to this picture.
It wasn't 0.
No, it has to be
Go
0.
down.
Yes, exactly, yeah. If it
Won't-
wasn't
won't
0,
turn around.
no, it'd still turn around. It just might go up and down as well.
Okay.
Let's call this distance to this here to here. Actually, let's call the whole distance here. Let's call it D. So let's call this force here, instead of 10, let's just call it F. And then how much is this one?
Minus F.
Minus F. Okay. So what's the turning force for this diagram? Whoops. Turning force. Turning force. Well, is this first one here clockwise or anti-clockwise?
No, clockwise, so minus.
Clockwise, yeah?
What's that?
This here
Yeah.
means turning force.
Turning force.
Yeah. Tau it's a Greek letter.
Okay.
Tau. It's Greek. You know Greek?
Yeah.
Like alpha, beta, gamma, delta, epsilon.
Okay.
Yeah.
Alright.
So tau. Now, this here is clockwise, so is it positive or negative?
Negative.
Negative. Okay, let's take the center here as the origin. So how big is the distance from here to here?
Half D.
Half D, very good. Whoops. D over 2. And what's the force?
The force. Where's
F.
F, yeah.
Or in this case it's 10. F. Now this one here, clockwise or anti-clockwise?
Clockwise.
Clockwise, so what's the sign?
Minus.
Minus also.
D2 minus.
So these are both minus. I'm sorry, my minus sign disappeared here. Oh, let me just write it again.
Take a lot of time.
No,
Really.
but you understand it clearly.
Yeah.
Turning force equals minus D over 2 times F. And then this one here, minus, what's the distance?
Will be plus.
No, it's clockwise.
Okay, minus will be
Minus D over 2 times F.
So will be plus. Minus and minus will be.
No, you don't put the minus here for this one. You only put
magnitude.
Yeah. Magnitude.
Magnitude, that means no sign.
Yes, for the force, yeah. You just put the minus if it's clockwise or anti-clockwise.
Okay.
So what's the total turning force?
0.
No?
No.
Yeah, try again. It'd be minus df.
2 go. How's that?
No, a half d and a half d is 1d.
Okay.
So it's 1 df. df.
Okay, minus 1 df. Okay.
And it's minus because it's anti-clockwise. Or it could be positive if it was... it's minus because it's clockwise. But it could be the other sign. So anyways, for a couple, the magnitude of the turning force just equals the distance between the forces times the magnitude of the force. Okay? So you have a simple formula to calculate the turning force for a couple. And this is it here. So you need to write this down, okay? Can you write this down, please?
This is the T or C.
It's tau.
It's tau. It's not T and it's not C.
Now,
Tau. Ted, do you know Greek letters? Look, Ted. Alpha,
What's the name?
beta, gamma, delta, couples. alpha, beta, gamma, delta, epsilon. Do you know these letters? Lambda, phi.
So this one.
This is tau.
Oh,
Steven?
You know all these letters?
yes, some of them.
Some of them. Well, here's a new one for today. Tau.
The Steven. The coupled word in the normal English not mean two?
It does. So that's why it's called couple, because there's always two forces. I think my pen's
Damage.
oh, a little bit better. No.
Worst.
I think actually this is broken because look, if I write here, it's okay. See? But if I write over here,
It will be far.
much, much worse. Oh yeah, I better plug it in too. Okay, are you happy with this? Can I go to a new page?
Yeah.
Okay, new page. Okay, so next thing now. Maybe, well actually that's just the only formula. So maybe we'll have a look at an example. So I'll do example 1 for you, okay? So here you have 4 points. Here, 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 and here. And you have 4 forces.
A, B, C, D.
A, B, C, D, yeah. A, B, C, D. And the first force is 1 Newton. 1. And the second force, 2. And then a force here, 3. And then, force here, 4. Come on, go away.
You should brush the left.
Yeah, I forgot. Thanks, Ted. Okay, so I have my 4 forces here. And the distance here is 1 meter, okay? So each distance here, 1 meter.
Okay.
And the question is,
Magnitude of the result.
find the magnitude of the resultant. Okay, so what's the total net force here? How much force do I have in total to the
4.
right?
4. The right?
Yeah.
Just 1.
No, there's 1 to the right and then minus 3 to the left. See here? 1 to the right,
Okay.
3 to the left. So how much in total?
Minus 2.
Minus 2, yeah. So minus 2I. Now how much force do I have going up?
4 minus 2. Minus 2 also.
Minus 2. What letter?
J.
J. So what's my net force? Square root. Square root what?
What is square root?
The square root formula, you know? Square root x squared plus y squared. Pythagoras. We did this before.
I forget.
Square root 2 squared plus 2 squared.
4.
8.
4 plus 4.
Yes. Do you remember, guys? Come on. Square this formula. Square root x squared plus y squared.
Okay.
Do you remember this?
Yeah.
Yes. Okay. I hope so.
And
Yeah.
The first last.
The first week. First week. Yeah. So the net force is 8. So do you remember in the last class that means you can add these together to make one force 8 newtons big. And the question is, where do I draw it?
Which one is the mid one?
Yeah, like where does it go? Yeah. So for the moment, let's just say, I don't know. Let me just draw it here. So maybe it's like somewhere here. And we'll call that root 8. Yes? Why did I draw it going down this way? Because it's minus 2 and minus 2. So it's going southwest. Now, I want to find this distance here. Let me call this distance x. So do you remember from the last class, how do I calculate it? Do you remember what I do? Firstly, I get the turning force of all the forces. So let me take this as the origin. What's the first turning force going to be?
0.
0. What's the second one? Positive or negative?
2 multiplied 1.
Positive or negative first?
Most positive because
Positive, yeah.
opposite way of the clock.
Yeah. 2. Let's go to the next one.
Plus 3.
Plus 3. And the last one?
Plus 4.
Plus,
4.
no, plus 0.
Ah.
Why is it 0?
4 to 0. Ah, 4 to 0.
Yeah. So what's the total?
5.
5. Now if I have only one force with distance x and magnitude root 8, what's the turning force of this single force? Root 8 multiplied by x. Yes?
No. 7.
Yeah.
Why is it 0 plus 2 plus 3? Why is that plus 0?
This one's 0 because the 1 is 1 multiply 0.
Okay.
And this one is 4 multiply 0.
And this one 2 multiplied.
2 multiply, that distance is 1. And then for this one here, it'll be 3 multiplied by distance 1 also. Yes? You look confused, Albert.
That direction in a distance up and down.
Ah, you think the distance should be from here to here.
Maybe from, yeah.
The distance is between here and the line. So if you imagine this making a line, it's the distance from here straight to the line, not to the point it's at. Okay? It's, you use the perpendicular distance, the shortest
So
distance.
the last one is 0 because.
Exactly, because this line at D goes through the origin. Yeah, very good. Yes?
Shouldn't 3 be negative?
Well, it's going anti-clockwise, so
So
that's
plus.
positive. If I take this as the center. How much do I have enough time? I better plug it in now in a minute. So anyways, the total's 5. Now this single force here, it's root 8 multiplied by x. So the total turning force is this. But what should this equal?
Equal 5.
Oops. It should equal 5. So I get x equals
5 over 4.
5 over root 8.
Root 8 is 4.
No, it's not. Root 16 is 4.
Ah, okay.
So that's the x. Is that okay for you, Ted?
Yes.
Now, I'm going to check.
Right.
Yeah, just one. I'm nearly finished. I'm going to change the second part for my example, okay?
Okay.
In my example now, what I'm going to say is this.
You mean the first question?
Yeah, I'm doing the first one, but I'm changing the second half. Suppose I put here a little wheel. Oops. Okay. And the wheel turns this way and turns this way, and maybe this is 1 Newton and this is 1 Newton.
So force will be
What's
0.
the turning force of this wheel?
Net will be 0.
No, well, the net will be 0. Correct. Can everybody please just listen? Please, Leslie, listen for one moment.
Okay.
If I add this, 1 minus 1, 0. So, does this change? Does this change?
Won't change.
Won't change,
Yeah.
because this is 0. So it doesn't change this.
Okay.
But, does this change? Yes, because there's more turning now.
Yeah.
From the formula I gave you earlier, what's the turning force of this wheel? And let's make it easy. Let's say the distance here is also 1. What's the turning force for this wheel?
D over 2.
D times 1. It's just the distance times the force, so that's 1.
So half
Now is it clockwise or anti-clockwise?
anti-clockwise, so it's positive, and the half of the to be half D over 2 multiplied 1.
No, the formula is D multiplied 1, not D over 2. For the total.
You want the whole.
Yes.
Okay.
So this turning force is positive 1. Yes?
Yeah.
So that just changes this 5 into...
6.
That just becomes 6 now. So the
6.
only difference now is
6 over 8.
that would be 6 over 8.
Root 8.
Root 8. So it doesn't change the net force, but it does change the turning force. And it means you have to put your net force somewhere else. And that's really it for today, for the first lesson. One example is enough because they're all similar to this. So you only have one new formula, but all the ideas are the same. Okay? Alright. I'll stop the recording now. So.